For this video, I'd like to talk about identifying different values in the domain. And remember with the domain of a function that it's essentially the set of all values of the independent variable, usually the x value, that can actually be used or graphed within a function. And with the domain, there's really only two issues that you need to be concerned with. For instance, if our function was 1 divided by x, you cannot divide by 0. So x cannot be 0. So you always want to be on the lookout for values of your independent variable, your x value in this case, that would lead to division by 0. The other issue that comes up, let's say we have the function g of x is the square root of x, is taking square roots or fourth roots or sixth roots of negative numbers. Okay, as long as the root is an even power, or an even root, I should say, then your domain will not have negative numbers in it. So for instance, the square root of -1, this does not have a real value solution. In fact, we give this a letter, I, since it stands for an imaginary number. This is the base unit for imaginary numbers. And with our standard xy coordinate plane, we just don't have a way to graph these. It is possible to graph imaginary numbers, but it's a fairly advanced idea. So we just need to concern ourselves with values that are positive when dealing with square roots. So for this one, we'd have to say our domain is all x values bigger or equal to 0, because it can be equal to 0. That's okay. The square root of 0, or essentially what number multiplied by itself gives you 0, would be 0. So that actually does have a solution that you can graph. So basically, what we have to do with these problems is test the different values and see if you actually get an answer. And we're basically looking whether or not we can actually graph a coordinate point at each of these different x values. So the main concerns are going to be division by 0 and square roots of negative numbers. So for this one, for instance, you might be able to notice right away that x cannot be 5. Since if you put 5 in here, like let's take h of 5, that is one of the values we're going to test. You have 4 over 5 minus 5, which leads to 4 divided by 0, which you can't do. And there's a couple different explanations for why you can't divide by 0, which I'm not going to go through now, but in essence, it just can't be done. We can't assign it a specific value. So for this one, we know that 5 would not be in the domain. But the other ones, they are going to be in the domain, because the only thing we have to be concerned with is this one point that we can't put in, because we can't divide by 0. But every other value should be fine. And there are no square roots, so we don't have to worry about restricting negative numbers. But if you're not sure, you can always just test the points. Like evaluate h of 0. That'd just be 4 divided by 0 minus 5, or negative 5. So you get a coordinate point 0, comma, minus 4/5. And when you plug in 4, h of 4 would just be 4 over 4 minus 5, which is negative 1, or negative 4. So again, you would actually get a coordinate point here at 4, comma, minus 4, and like I said for above, at 0, comma, minus 4/5. But you won't get a coordinate point here because at 5, when you plug 5 in, the function is undefined there. So let's move on and try some other examples now. And what you can notice right away with this function is that you don't have any division by your variable, and you don't have any square roots. In fact, you might even recognize this as a linear function. It's essentially the function that represents a line, where our slope is -2 and our y-intercept is 5. But if you're not sure about that, just plug in the points and see if you get values. So we can do g of 0, that would just be 5, since -2 times 0 is 0. G of 2, we would get 5 minus 2 times 2, which is 4, which equals 1. So again, as long as you're getting a value and it's not undefined or imaginary, then these points are in the domain. And we'll just wrap it up by plugging in 8. We get 5 minus 2 times 8. So that would be 16. So you get 5 minus 16, which would be -11. So again, you got a value, so that means it's going to be in our domain. And moving forward, so now this one we have square roots, so we have to be a little bit careful. And basically, whatever your square root function is, you just want to say that whatever is underneath the square root sign, everything has to be bigger than or equal to 0. So x minus 10 has to be bigger than or equal to 0, and then from here you can solve. So adding 10 on each side, x has to be bigger than or equal to 10. It can't equal 10 because if we put in 10 into the function, we get the square root of 10 minus 10, which is the square root of 0, which we know from above is just equal to 0, since 0 times 0 gives you 0. And this point right here we can conclude is in the domain, but the numbers less than 10 are not going to be in the domain. But if you're not sure about that, like I said above, just plug these numbers in and see what you get. So if we do h of 0, we get the square root of negative 10. But this is the square root of a negative number. So in other words, it is imaginary. It's an imaginary number. We cannot graph it on our standard xy coordinate plane. And likewise, you'll get a very similar result when you plug in 5, because 5 minus 10 is negative 5. So this one is also imaginary, and if they're imaginary, they're not going to be in the domain. And this one, f of x, it looks like we have division here, and it's okay if your numerator is equal to 0. So for instance, let's start with that point 0. So f of 0, you get 0 divided by 0 minus 7, or 0 divided by negative 7. So this is okay. Whenever the 0 is in the numerator, you're cutting 0 into this many parts, essentially, and asking how long would each part be. It's a little bit tricky to think about it that way with negatives, but regardless, if you had 0 divided by 3, the way I like to think about it is you have 0 loaves of bread, and you want to give them out equally to 3 people. How many does everyone get? Since you don't have any loaves of bread, everyone would get 0. And it is the same thing with negative numbers. It's just maybe a little bit more complicated to think about. So if we were to plot this point, it would just be at the origin, at 0, 0. So that value is fine. But in the denominator here, we know that if we use a value like 7, we're going to end up with division by 0. Since f of 7 leads us to 7 over 0, which we just call undefined. And so that one at 7 would not be in the domain, but negative 7 should be fine. Let's just prove that to ourselves. So f of negative 7 is minus 7 over minus 7 minus 7. So minus 7 over negative 14, which would be positive 1/2. So that one is in the domain as well. And let's do one final problem where, again, we have a square root. And what we could do is start with our function and just say whatever is underneath the square root has to be bigger than or equal to 0. So we can say that this whole expression here, this term minus 2x, has to be bigger than or equal to 0. So minus 2x has to be bigger than or equal to 0. And then we want to solve for x, so we divide everything by negative 2. But remember, when dealing with inequalities, if you divide or multiply by a negative number, that you have to flip the sign. So we know that 0 divided by anything is 0. And we know that minus 2 over minus 2 is just 1, so you get 1x. But since we divided by negative 2, the sign would flip. So in this case, x has to be a negative number, or 0. Because if you put in a negative number, like let's say negative 2, which we do have to check, then negative 2 times negative 2 gives you a positive number under the square root. But if you put in a positive number, then you're going to end up with a negative result underneath the square root, which is imaginary. So let's plug in negative 2 and see what happens. Though, based off what we figured out here, we already know that this is going to work and these aren't. But let's prove it by just plugging in the numbers. So you get negative 2 when you plug that in is the square root of minus 2 times minus 2, which again is just a positive 4, which has a nice clean square root of 2. So that one is definitely in the domain. But if you put in 2, you get the square root of minus 4, which we know is an imaginary number. And when we put in f of 4, you get minus 2 times 4, or the square root of minus 8, which again, that is an imaginary number. So with these, as long as whatever is under the square root ends up being positive when you put in your different x values, then it'll be in the domain. But if it ends up being something negative, like at 2 and 4, or really any positive x value, then you're going to deal with these imaginary solutions.